Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Freddie Lawton from Business Review, and I'll be your host. It is our pleasure to have Evoqua Water Technologies with us today, who will be discussing granular activated carbon, sanitization, and steam stripping. Today's guest speakers are Jim Ceklosky, who is a business developer for the food and beverage market for Evoqua Water Technologies, and Harry DeLonge, who is a senior technical expert and president of Tri-Lake Group, a division of DeLonge Technologies. I'd like to welcome you to our webinar platform On24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link they receive via email to rejoin the session. In order to ask questions, you can send them in via the questions widget, so just type them into the box at the top left-hand corner of your screen and click submit. We will allocate around 10 to 15 minutes at the end of the session to address any questions or thoughts that you may have. Please use the yellow help widgets if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But now, please allow me to welcome Jim.
Thank you, Freddie. And again, I would like to extend a good morning to those attending in North and South America, and potentially a good afternoon, and maybe even a good evening to those attending from the rest of the world. As Freddie mentioned, my name is Jim Ceklosky. I am responsible for food and beverage business development for Evoqua Water Technologies. I have a BS and an MS in chemical engineering, and I have over 20 years of experience. My colleague who has helped me with this presentation, Harry DeLonge, he is our senior technical expert, president of Tri-Lake Group. He has consulted for many companies, including Pepsi, Cadbury, and many other food and beverage companies around the world. Harry has over 40 years of experience in the food and beverage industry, so we thought it would be a good idea to share some of our experience with you today. So first, I thought we'd start off by talking about what is activated carbon. And the first bullet point talks about activated carbon being a highly porous and absorptive carbon-based media. And we'll talk a little bit more about this later on in the presentation. It has a very complex structure with networks of pores, and I have some pictures to kind of illustrate that network of pores. Now, when we talk about activated carbon, there are typically three types of activated carbon: powdered, granular, and extruded. Now, powdered activated carbon, typically called PAC, P-A-C, ranges from sizes of around 5 times 10 to the negative 7 to 1.5 times 10 to the negative 5 millimeters. The second type of activated carbon is granular activated carbon, or called GAC, G-A-C. And its size range is certainly larger, around 0.2 millimeters to around 5 millimeters. And the third type of activated carbon we typically hear of is extruded, and these are cylindrical pellets, which can range from sizes of 1 to 5 millimeters in diameter. So if you take a look at the image to the right, if we go from right to left, you can notice that the furthest one to the right on that image is powder activated carbon. As we move to the left, the middle image in there is granular activated carbon. And the third one is the extruded cylindrical pellets. And it's also worth noted that the middle one, the granular activated carbon, is traditionally used more so in the food and beverage industry. Now, activated carbon can be made from various sources. Typically, it can be made from coconut shell, peat, wood, or coal. So let's talk a little bit about how activated carbon is manufactured. There are two means to manufacture it. The first one is steam activated. Now, steam activated carbon is typically used with coconut shell based or coal based carbons. And the process of steam activation occurs in two steps. The first step is called carbonization, where it typically occurs at around 1300 degrees F. And what we're really trying to do in this step is we're trying to dehydrate the material and devolatilize it. The second step in the steam activated portion is the actual activation. And this is where we utilize steam at temperatures of around 1400 to 1800 degrees F. And what this does is this helps enlarge the pore structure, increase the internal surface area, and makes it more accessible, meaning more accessible for removal of constituents. So you can see now that with this activation step, we have some ability to vary the size of pore sizes, therefore allowing us to potentially produce carbon specific to remove specific constituents that we're looking for. So an example of this would be if we needed to have a more open pore structure to absorb smaller molecules from, say, a solution, such as water purification. And if we were to compare that, if we're just trying to move some large or color molecules, we wouldn't need as tiny of a pore structure. So now let's talk about the second way that activated carbon is manufactured, and this is chemical activated. So chemical activated carbon is typically used with wood and peat-based carbons. And again, this has two steps. The first step consists of mixing the raw material with an activating agent. And this activating agent is typically zinc chloride or phosphoric acid. And what these activating agents do is they cause the material to slightly swell. Now the second step of this process, the carbonization, that occurs at temperatures around 700 to 900 degrees. And the chemical that we used in step one acts as a support, and it does not allow the char that's produced when we heat it up to shrink. Therefore, it kind of keeps the intrinsic pore network open and acceptable to constituents. So now we're going to talk a little bit about some of those key properties of activated carbon. And the first one is this intrinsic pore network. The porosity of activated carbon offers a vast surface in which adsorption can take place. So we can see, and looking at the picture, the lattice structure of activated carbon allows for the removal of impurities from gases and liquid media through a mechanism called adsorption. So let's talk a little bit about what adsorption is and the two types of adsorption. So adsorption is defined as the attachment or adhesion of atoms, ions, or molecules, which we typically call adsorbates, from a gas or a liquid onto the surface of an adsorbent, which in our case is activated carbon. Now, adsorption typically occurs in two manners. There's a physical adsorption, which are weaker forces, and they're typically called van der Waals forces or London dispersion forces. And then there's chemisorption, which is relatively strong forces of attraction, where in some instances you have actual chemical bonds between the adsorbates and the chemical complexes right on the surface of the granular activated carbon. So moving on to a couple other key properties of activated carbon, the next one is surface area. And it's safe to say in general, the higher the internal surface area, the higher the effectiveness of carbon. So if we take a look at the image right below that bullet, a spoonful of activated carbon equals the surface area of a soccer field. So you can imagine that it's an incredible amount of surface area in just one spoonful, yet alone if you can imagine a carbon tower that may be several feet in diameter and several feet high. The next property we're going to talk about is total pore volume. And that's typically measured in milliliters per gram. And what that refers to is all the pore spaces inside a particle of activated carbon. So one other final key property that we're going to talk about is the pore diameter of the carbon itself. And there are three categories of the pore diameter. We look at micropores, which are a diameter of less than 20 angstroms. We have mesopores, which are a diameter of between 20 and 500 angstroms. And then we have macropores, which are a diameter of greater than 500 angstroms. So if you look down at the image on the right, you can kind of get a feel for where some of these pores may be located. So maybe up near the surface of the activated carbon, we could have those larger macropores, and those would be the pores that maybe catch some of the larger color molecules. And then maybe as we go deeper into the activated carbon, you would get into the mesopores and potentially even the micropores. So that image kind of shows you that intrinsic network. It really gives you a good idea of how complex the activated carbon can be. So let's talk a little bit about why carbon is really important to us in the food and beverage. Why are we really even using it? Well, carbon really helps us remove a lot of items, and the first item that helps us remove is chlorine and chloramines. Many municipalities or sources of water utilize chlorine and chloramines for disinfection. So carbon is a means to help us remove that excess chlorine, which would help us protect potentially downstream equipment that's maybe sensitive to that chlorine or chloramine. It also helps us remove organics. And some of the organics that we're typically concerned with are the trihalomethanes, or known as THMs, the haloacetic acids, HAAs, and just other general organics. The third thing that carbon helps us remove is sometimes we're looking to remove some odors, or even the fourth item, some off tastes. So carbon has a lot of uses for us in the food and beverage industry, and that's why we utilize it a lot. And it is worth noting that carbon is considered the best available technology for removing small molecules such as THMs. So if you have a THM concern or a challenge, maybe carbon is the way you should go. So we're going to talk a little bit now about exactly why are sanitizations needed of my activated carbon. I have this tower. Why do I need to sanitize it? Well, we really need to sanitize activated carbon because we want to prevent microbial contamination within the product, which could ultimately improve the system operating efficiency. You see, if we have bacteria growing in our carbon or carbon tower, it can cause some extreme issues. And those issues could be that the carbon itself gets blocked or clogged. Therefore, all those sites and that intrinsic network that you had seen images of before really become unuseful, and then whatever you're trying to remove could potentially flow downstream. So we really want to protect the carbon, keep those sites open and available to remove whatever constituent we may be looking to remove. So the other point about about sanitizations is that without a proactive organism control, our carbon tower can become a source of bacteria growth. And this growth can create potential biofouling, which could in turn affect our equipment downstream. For example, if we have biofouling that's, let's say, growing within our carbon tower, it could affect an RO that's downstream of that, therefore causing us to perform more maintenance on the RO. So we really want to have proactive sanitizations of the upstream equipment to protect our downstream equipment. So Freddie, I think it's time for our first polling question.
Yeah, excellent. Thanks for that, Jim. So that's right. It's time for the first poll that we'll be running in today's session. So audience members, if you could please select the answer that is relevant to you and then just click on submit. So the question is, how often do you sanitize your carbon tower or towers? So a few options there for you. So daily, weekly, monthly, biannually, or never. So audience members, if you could select your answer now. And Jim, perhaps you could briefly comment on the question just to give our audience a bit more time to vote.
Yeah, sure, Freddie. So yeah, this is always something, if you have activated carbon towers, you may even have standard operating procedures. So we just put some samples, whether that be daily, weekly, monthly, biannually. Hopefully nobody's really selecting never, so it'll be kind of curious to see what the results come out to be.
Perfect, thanks for that, Jim. Let's have a look at the results. Well, in fact, we did get a few people who put never down, but leading answer there with 40% is biannually. What do you reckon, Jim, more or less what you're expecting?
Well, yeah, I mean, I guess I'm not surprised. I'll address the monthly one. I would think that maybe more so I would see a lot more on the monthly sanitizations. But if you do have more of trihalomethane issues and concerns and haloacetic acids, I can see somebody going to a biannual basis. And again, I see some of the answers are even at 10% or weekly. So it's good that we have a lot of people sanitizing. The never ones, I guess I'd just be curious on the situation that they're using the carbon at, and then why they aren't sanitizing. And maybe there are circumstances, but I guess I really couldn't address that one until I further understood what they're trying to do and remove with the activated carbon. Okay, so now that we've gone through the first polling question, we're going to keep on moving along here. And before we go into discussing sanitization of carbons, we wanted to point out that there is a difference between sanitization of carbon and carbon towers and steam stripping. So what steam stripping does is it helps us remove those trihalomethanes, the haloacetic acids, and other organics. And in order to do steam stripping, there are a couple requirements that you should have. One is you should really only perform steam stripping with a stainless steel vessel. And along with that, you should also be mindful of any instrumentation that you have within that column and making sure that it is of the material of construction to take the temperatures that we're going to talk about. Another point that's worth mentioning in steam stripping is that there are some guidelines for steam quality. ASME and the FDA have steam quality recommendations. So if you're doing that, I would make sure you're aware of what their recommendations are, and so that you're not bringing in anything that is unwanted into the activated carbon tower. Now, in general, I'm just going to give a brief overview of the processes. So by all means, this isn't the exact step-by-step way that some of these procedures are going to be performed. I'd recommend that you reach out to your vessel manufacturer or even a trained service provider for additional details. And if at the end of this presentation you don't have a trained service provider, you can always reach back out to Evoqua. We have services to help you with that as well. So let's talk a little bit about the process of steam stripping. Typically, it's a manual process. So we're valving out the system, and we're performing that with some operators on site. And the basic steps are the following. We typically will start with a backwash of the carbon tower. Then we'll open up the vent and drain the tower of water. After it's completely drained, we'll valve into steam and wait till our top temperature gauge reaches around 212 Fahrenheit. So once we reach the point of 212 Fahrenheit, we pretty much start the clock, and we'll typically run the steam for about 6 to 8 hours at 212. And then once we reach that 6 to 8 hours, we'll turn off the steam and we'll allow the tank to cool. That tank will cool down to hopefully around 95 degrees or so. That's where we like to see it. And that typically takes between 4 and 8 hours. Once that cooling has occurred in that 4 to 8 hour window, we'll then go ahead and backwash and rinse the carbon tower. Now, there are some potential challenges that we have with steam stripping. We could have channeling, where we have steam, maybe, let's say, if we look at the image to the right, maybe we have steam going up the left-hand side of the column and none is going to the right. Therefore, we're not exposing any of that carbon to the steam. So there is a concern that channeling can occur when doing steam stripping. As you can see, it's a time-consuming process as well. But in some instances, it's a very necessary process to do, especially when you're trying to remove, when you have trihalomethanes and haloacetic acids that are of concern. And then the third challenge you can see is that there may be a challenge with condensate removal. Everybody has a different type of wastewater permit, so you have to be mindful of if there are items coming off into the condensate when we're removing that. what is the impact on my wastewater permit? So now that we talked about steam stripping, we're going to jump into the sanitization of activated carbon towers. Now, there are 3 ways to sanitize. The first one is going to be steam, which we'll talk about. The second one we'll talk about is caustic sanitization, and the third is going to be hot water sanitization. So let's talk about steam sanitization. Again, the goal here would be to sanitize the carbon and the vessel itself. And it's very similar to the process of steam stripping, which we talked about before. Again, the preference here is to utilize stainless steel vessels, and again, be mindful of the instrumentation that you have within that vessel, because it needs to be able to handle the higher temperatures, the 212s that we're talking about. The concern about steam quality is also there again, so please refer to the ASME and FDA for steam quality recommendations. And again, as described before in the steam stripping, I'm just going to kind of highlight some of the steps here, and please feel free to talk to your vendor manufacturer or a trained service provider for the additional specific steps for your process of steam sanitization. But this process is, again, a manual process. We're going to backwash the carbon, open the vent, and then ultimately drain the carbon. Once we have the carbon drained, very similar to the steam stripping, we're going to valve into steam. We're going to bring it up to temperature to around 212. But here's the difference now on the steam sanitization as compared to the steam stripping. We don't have to run the steam as long. Typically, we'll run it for about an hour at around 212. Then we allow that tank to cool back down to that 95 degrees F, and that typically takes 4 to 8 hours. Once those 4 to 8 hours are complete, we'll go into the backwashing and rinsing of the carbon tower and then be able to put it online. Some of the potential challenges that we see are very similar to the ones we saw with steam stripping. The channeling is a potential there. It is time consuming, but not as time consuming as the steam stripping. And then again, condensate removal is a concern and you just need to pay attention to what you're permitted for. So let's move to our second type of sanitization. This is a caustic sanitization. And this again will sanitize the carbon and the vessel itself. But the use of caustic sanitization is really only used when we have a seriously contaminated carbon. And we really want to be careful about utilizing this means to sanitize, because we only really recommend experienced personnel to do this. And if you don't have any experience with this, please contact a company that has previous experience, because part of this process involves obviously the use of caustic, which can be very harmful, and you're also utilizing acid. So there's a lot of potential harms out there. So we'd really only advise this if you have experience doing it, and if not, please reach out to somebody who does have the experience. So leading into the potential challenges, like I kind of talked about already, it's a dangerous process, but sometimes it has to be done. We just have to use the proper personnel protection. It is time consuming as well. And in this instance, we do have some issues with, you could potentially have issues with the removal of the effluent that you've created during the sanitization process. So we're going to move to our final sanitization capability, and this is hot water sanitization. Again, it's used to sanitize the carbon and the vessel. We typically recommend this to be with stainless steel vessels only. Now, I'm not saying that it cannot be done with non-stainless steel carbon towers, but you really need to, again, contact your vessel manufacturer or even contact myself, and we have to do a little bit more, I'll say, homework on whether the vessel can actually take the temperatures that we're going to talk about below. Now that we're not using steam, our concern is with water quality. And we do need to use some quality water to sanitize this, hot water sanitize it. And we have clients who've typically used filtered water or RO permeate water or some other means of water. And traditionally this, like the other processes, has been a manual process, which really starts with a backwash. Then once we've done the backwash, we kind of can come into doing a recirculation for about 1 hour. Now the temperatures we're talking about here are only 185 degrees, so less than our 212. And that's why I made mention that there's a possibility to do non-stainless steel carbon vessels, but we really have to see what that lining is on those vessels. So after we recirculate for about 1 hour at the 185 degrees, we want to allow the carbon tower to cool again, and that's to come back down to that 95 degrees F. And again, that takes about 4 to 8 hours. So now we're going to kind of move into what an ideal sanitization should look like. So the first thing we think about when we think about an ideal sanitization is we'd like to think that it's simple. One push of a button to initiate. That it's an automated for a complete backwash, and you're able to sanitize to your exact requirements. We also like to think that an ideal sanitization can be efficient and sustainable. And what this means is that we'd like to be able to sanitize the carbon while it's suspended. And what this does is this exposes all of the surfaces that we had talked about before, that intrinsic pore network. So by sanitizing it while it's suspended, we really expose all of the carbon surfaces. The sustainable portion, it helps save up to 75% of the backwash water. That would be an ideal sanitization, that I'm not using all the water that I traditionally would use. Another aspect of ideal sanitizations are heat. The heat is applied when we suspend the carbon during a backwash, kind of like what I just talked about just above. And what this really does is this maximizes our bacteria kill rate. Again, we have all those surfaces exposed, and it allows that hot water to hit all of those areas and maximizes that kill rate. And by expanding the bed, we eliminate a lot of those issues and concerns of channeling that we had talked about before with steam, where we really don't know if we're really getting the entire bed. But once we expand a bed, we have a pretty good confidence that we're getting to all portions of the activated carbon. Now, the final thing about ideal sanitizations are we'd like that system to be flexible. And what I mean by that is we'd like to be able to either do a single column or multiple carbon towers. We'd like to be able to potentially extend the runtime of this system really at no extra consumption of water and with a minimal energy increase. We also would like to be able to retrofit it to recirculating heat to sanitizing potentially polishing filters and UVs that might be in the system. And we've seen in the previous sanitizations, in the previous slides, that there is a long period to cool down the tower. And in an ideal sanitization, boy, we'd like to limit those 4 to 8 hours and reduce them. So there's systems that can be fitted for immediate cooling that can allow that 4 to 8 hour window to shrink, therefore getting us into operation sooner. So if you look at the image that I have below, this is an example of a hot water system. If we start from left to right on the image, you can see that there are some fines filters on the left. Then as we move across the skid, there's a pump that pushes the liquid through. We have a heat exchanger that in most instances is heated by steam, and then it would flow back into the carbon. And it would stay in this loop, and this is that loop that I would say we bring that up to 180 to 5 degrees, and we recirculate it for an hour. So now I think we are ready to move on to our next polling question, Freddie.
Yeah, great stuff. Thank you, Jim. So it's time for the second poll that we're running in today's session. So exactly the same process. Audience members, if you could please select the answer that is relevant to you and then just click on submit. So the question this time is, do you perform your own carbon tower sanitizations? You've got 3 possible answers there. Yes, with steam. Yes, with hot water. Or no, we have a service provider handle them. So audience members, if you could select your answer now, and once again, Jim, perhaps you could briefly comment on the question to give our audience a bit more time to vote.
Yeah, sure. So yeah, this is a pretty straightforward question. And it all really depends upon the personnel that you have available for you at your facility. But we're really looking to see whether you're performing them with steam or hot water, or you have a service who can come in, and we know that there are services who can kind of roll up their equipment and perform that sanitization for you. So we're really just trying to poll and see where our audience is at with this type of question.
Okay, great. Let's have a look at the results. So leading answer by far there. So with 64%, that's yes with steam. What do you reckon, Jim?
Well, I'm not overly surprised by that. I would have guessed that the steam was probably the leading candidate here. And then I see that we do have some people who utilize hot water as well. And then, like I had said prior to the question being answered, we do know of service providers. So not surprising on the spread here, but it's good to see that we have a lot of them utilizing steam. And again, the important thing I mentioned is the concern with the steam is, of course, is making sure that we don't have any channeling. And that's always a concern when we utilize steam. Whereas if we were to use a hot water system, we expand the bed with liquid. So if you are not getting channeling, that's great, but that's just something to be mindful of when you're utilizing steam. So we're going to move along here and talk about the benefits of an ideal GAC sanitization. So in general, more effective sanitizations mean less frequent sanitizations and more operational time. And who doesn't love that, right? If you're producing any kind of bottled water or carbonated soft drink, you want to be up more than you're down. More thorough sanitizations also help reduce microbial counts and biofilm formation. So like I had said earlier in the presentation, we don't want to have this biofilm forming within the carbon tower because ultimately that could affect some downstream equipment. And those top two bullets that we talked about really talk to better system quality control. The third bullet here, hot water sanitizations reduce the chances of contamination from steam supply. And what I mean here is that we all use some sort of chemical in our boilers to protect them. And there are, in some instances, where you get carryover of these chemicals into your steam. So you certainly don't want to have that steam have any of those chemical carryovers. So if you had a hot water sanitization, you don't necessarily have those concerns. And like I had mentioned earlier, recirculating this heated water means you're reducing water consumption by up to 75%. And again, in today's day and age, if we can save water, it's good for the company's reputation to say that we're not just putting all this water down the drain, we're actually being proactive and recirculating and recycling some of that water. So I just want to move along to our conclusions now and just kind of review what we had talked about. So at first we talked about some of the basics of activated carbon, the key properties such as surface area and that intrinsic pore network. Then we talked a little bit about the importance of GAC in the food and beverage industry, where we talked about it being able to remove the chlorine, the chloramines, the THMs, the HAAs. We then moved on to talking about why the sanitizations are really required. Then we started to talk about steam stripping and the difference between steam stripping and steam sanitization. And remember, the real difference between steam stripping is that we're really trying to remove the trihalomethanes, the haloacetic acids, and it's the duration that we're steaming. We're steaming in that 6-hour range as opposed to 1 hour where we'd be steam sanitizing. So then we moved on to the various types of sanitizations, which would be steam, caustic, and hot water. And again, I just want to point out that the caustic one, please consult sources. It's a dangerous process. It can be done, but just use a lot of caution doing that. And then we talked about the hot water sanitizations as well. And then we kind of rolled into talking about what an ideal sanitization looks like, whether it be simple, and it be efficient and flexible. And then we talked about what are the benefits of that ideal sanitization. So with all that being said, I want to first thank everybody for their time today. And we're going to move on to the question and answer session. But before we do that, On this slide, you'll see that I have my contact information. So if you do have any additional questions outside of this webinar, please feel free to reach out to me. My email address is there. We also have some resources available for you at evoqua.com. And if you're interested to learn more information about a hot water sanitizable system, there's a link for our hot system, which we call a heat optimized technology. And on that link, you can find additional information with respect to the skid that we offer. Freddie, I think we're going to open it up to questions and answers now.
Yeah, perfect. Thank you, Jim. So just a quick reminder for the audience, in order to ask questions, you can send them in via the questions widget. So all you need to do is just type them into the box at the top left-hand corner of your screen and click Submit. So let's have a look at the questions which had already been sent through so far. So we got one for you here, Jim. So someone says, how often do you recommend to sanitize carbon towers?
Well, you know, we had that polling question out there, so I wanted to try to get a feel for, you know, how often people did sanitize, and there is really no set time frame, right? It really comes down to the, let's say, micro condition and biological quality of the incoming water that you may have, and potentially what product you're making, along with, you know, what your quality assurance team might say is acceptable, is an acceptable microbial level. So we have many clients who sanitize daily, weekly, and like I said, as we saw earlier, you have biannually, monthly, so there is no set answer to that question. It really depends upon a lot of circumstances.
Great stuff, thanks for that. I've got another question here for you. So someone says, can sodium bisulfite be used in lieu of carbon towers?
Yes, the short answer is yes. But there are some challenges in using sodium bisulfite. Specifically, you know, we have seen clients who, you know, will set their chemical dosage and they kind of set it and forget it, right? They don't really confirm that their system is calibrated at certain periods, so maybe at times they may be overdosing the sodium bisulfite, underdosing the sodium bisulfite. So the only challenge with using sodium bisulfite is, like I said, I would be concerned that if you have a proactive maintenance where you're confirming that I'm dosing X parts per million in there and we're doing that on a regular basis, then certainly it can be used.
Great, thanks again, Jim. Next question here for you. Someone says, what instrumentation is typically used to monitor chlorine breakthrough following a carbon tower?
Typically, we use an ORP instrument to utilize this. So if we were looking at a system where let's say we have an activated carbon, we maybe have some post-filtration, a cartridge filter after that, and then let's say we have a reverse osmosis equipment downstream of that, we would have the ORP just upstream of the reverse osmosis, just to make sure we don't have any breakthrough, because those of you who are familiar with reverse osmosis, having a lot of chlorine leakage into the membranes of the reverse osmosis can cause premature failure. So the ORP is usually the instrument that we use.
Thanks again, Jim. Next one here for you. Someone says, some companies prefer acid-washed carbon. Can you comment on that?
Yeah, sure. So the reason some companies prefer this process of acid washing is that it removes and reduces some of the inorganic content that might be on the carbon after, let's say, if we have steam-activated carbon. So it'll remove the additional inorganic content. And this inorganic content could be something like calcium, magnesium, maybe even iron. So by removing these, what it does is two things, actually. It helps lower the effluent TDS, total dissolved solids, once we get that column started up. And it also has an effect on the pH as well. So there can be some effects on the pH if we don't have an acid wash carbon. So that's why we have certain clients who prefer acid wash carbon.
Thanks again, Jim. Next one here for you. Someone says, once the carbon is exhausted, can it be reactivated?
Yes, actually carbon can be reactivated. It's very common, to be honest with you. However, we have found that most of our food and beverage clients choose not to use reactivated carbon back into their process. Typically, that reactivated carbon can be used in other industries, maybe used on the wastewater treatment side. So again, typically we don't have the clients willing to reutilize the reactivated carbon, at least on the, let's say, the beverage side of it. But if they have a wastewater treatment portion, they're sometimes more willing to utilize reactivated carbon.
Thanks for that. Next question here for you. Someone says, what is the typical pressure steam required to perform a steam sanitization?
So every situation is a bit different. And before I kind of give you a numerical answer, I'm going to again advise you to consult your vessel manufacturer on this and potentially your service provider. But with that being said, some of the typical steam pressures we've seen go anywhere from around, let's say, 15 to 30 psi, because remember, we're only really trying to heat the tower up, the top of the tower up to around 212. So 15 to 30 psi is a typical number we see.
Thanks, Jim. Got another one here for you. So someone says, how long should the contaminant be in contact with the GAC?
Again, it's a good question. We get that question a lot, actually. So the length of time in which the contaminant is in contact with the GAC and the GAC tower really influences the adsorption process. So what I mean by that is the longer length of contact, the greater the number of contaminants that will be removed. A greater amount of activated carbon and a slower flow rate will kind of improve the effectiveness of the filtration process. So we look at bed depth and flow rate as being critical parameters. Carbon towers, we typically design them or engineer them to provide a specific, we'll call it residence time of water to be in contact with the carbon bed. And we refer to that residence time typically as empty bed contact time. So in general, we have to look at the specifics surrounding your column, the dimensions of your column, what you're trying to remove, and then we can kind of come to the conclusion of how long we need to have that empty bed contact time be.
Great, thanks a lot, Jim. That's about all the time we've got. In fact, don't worry if your question wasn't answered during this session. Jim and Harry can get back to you personally at a different time. Jim, is there anything you'd like to add before we conclude? Perhaps a little final message for our audience members?
Well, I just want to, again, thank everybody for attending. And please, like Freddie had said, if we didn't get to your questions, we have them logged, so we will be able to answer back to you. And again, Harry and I just like to thank you one last time for attending.
That just leaves me to thank Jim and Harry for what was a great presentation and to thank Evoqua Water Technologies for sponsoring this session. To the attendees, you'll receive an email shortly telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is www.business-review-webinars.com. Once this webinar ends, today's survey will appear in its place, and we'd really appreciate it if you answer the questions in there. We look forward to sharing further webinars with you, so please do keep an eye on the website just mentioned and follow us on Twitter at BRWebinars for daily updates and join our LinkedIn group, Business Review Webinars. Thank you once again, and I hope you all have a nice day.